Hello everybody and welcome back. We are continuing with our astronomy unit. Today we're going to be focusing on the seasons and what causes the seasons, as well as talking about the tides and what actually causes the ocean to rise and fall. So for simplicity's sake, I'm going to split this into two videos. So the first video will be talking about the seasons. It should be a little bit quicker. And then the second video will talk about the tides. So before you get started copying anything or watching either one of these videos, you want to make sure that you've downloaded your interactive notebook slides for the day. And as always, they will be linked in your warm-up of this lesson. So let's go ahead and get started. Our first objective that we're going to be going over is explaining how seasonal changes are due to the tilt and the revolution of the Earth. And then our second objective is to explain how tides are affected by the gravitational interaction among the Earth, the Moon, and the Sun. So just to review, why are planets round? Why do they have a circular shape? So when they're formed after the Big Bang and all the clouds and the dust and the matter came together and swirled together, it formed round planets. And why did that happen? It's because of gravity. So the Earth, like all planets and the stars, have a gravitational pull at their center. Remember, that's what keeps you grounded on the Earth. Since gravity pulls with equal strength in all directions, this makes them round. So the force is equal and opposite, and because there is the force of gravity in all directions on a planet pulling it to the center, it just makes them spherical, so it makes them a circle. But there is something called an equatorial bulge that we have to talk about. And this little guy down in the left-hand side, it says, I guess I better hit the gym, because he's got kind of a little bulge in his midsection right around the equator. So what is this? The equatorial bulge is when the Earth bulges out in the middle along the equator because of centrifugal force from the speed of the rotation. So basically, our Earth is spinning so fast, the force from the spinning kind of squishes our Earth down a little bit, and it causes the middle section of our Earth to bulge out. Okay, and this happens at the equator, and our equator is located right in the middle of our planet. Okay, so the force caused by the spinning of the planet causes kind of like our little sphere to smush down and causes a bulge right in the center. Okay, and if you're interested, you can watch this YouTube video. This lady basically demonstrates the spinning and how it causes the top and the bottom to kind of flatten a little bit and causes the middle to bulge out. So let's talk about what causes the seasons. So the different seasons actually exist because our Earth is tilted, and we saw that in our warm-up today. So if our Earth did not tilt on its imaginary axis, we would have the same season all year round. And that would really honestly be no fun, because I can't imagine it being hot or cold all year. And again, here is a video that you can watch to help further your understanding in case you need it. So what 4 seasons do we have? We've got summer, spring, fall or autumn, and winter. Okay, so those are the 4 seasons. And those 4 seasons are characterized by changes in weather patterns and just temperature. And the reason that we have changes in weather and temperature is based on where we are in our Earth's orbit and how we are tilted on our axis. So just to review, we know from Kepler's laws that we learned about yesterday that all of the planets in our solar system revolve around the sun. And Kepler discovered that they move in an elliptical orbit, so they do move in an oval shape. Okay? And we know that our Earth rotates on its axis, and one full rotation is 1 day. So while the Earth rotates on its axis, it takes 24 hours to make one full rotation. Okay? And we do know that night and day come from this rotation of the Earth. The Earth also orbits around the sun, and it takes 365.25 days to make that complete revolution. And remember, it's an extra 4th day, and that's the reason why every 4 years we have a leap year. Okay? So again, our Earth is not straight up and down in space. It's tilted, okay? It's tilted on its axis, and it moves around, it revolves around the sun. So it spins at a tilt on its axis, and it revolves around the sun. And then remember that the axis is tilted at roughly 23.5 degrees. So if this is straight up and down, the 23.5 degree tilt would be at this angle. So this is what the orbit actually looks like. So remember, we're spinning on our axis, and as we are spinning, rotating on our axis, we are also revolving around the sun. So that's where the season comes in. So the Earth tilted axis is what allows us to have the seasons. So the 4 seasons are also based on Earth's position to the sun. So we've got, again, spring, summer, fall, and winter. And this is caused directly from the tilt of the axis of the Earth. So when the Earth is tilted away from the sun, it gets less solar radiation. Okay, so the sun emits energy in the form of radiation, and that radiation from the sun is what heats up the Earth. So right now we're in summer. Our hemisphere is facing towards the sun, and we are getting a lot of radiation daily from the sun, which is causing it to be hotter, right? It's been upper 80s, 90 degrees here recently, okay? But when the Earth is tilted away, there's less radiation, and that means the temperatures will be colder. So if we're tilted towards the sun, we've got high radiation and warmer temperatures. If we're tilted away from the sun, we've got lower radiation and cooler temperatures. Okay? And this is just kind of an example of what I'm talking about. So here are the sun rays from June. So we know in the northern hemisphere, June is kind of spring, the start of summer. Then we have these direct solar rays that are coming in and heating up the northern hemisphere, which is causing summer. And then in December, when we know it's winter, we have the solar radiation coming in on the southern hemisphere. This is why the seasons are reversed in northern and southern hemispheres. So right now, we live in the northern hemisphere. We're experiencing summer, whereas those that are in the southern hemisphere are experiencing winter right now. Okay, and then here is an example on the bottom. So here during June, we've got a large incoming and a direct hit of these solar radiation that's causing warmer areas, and then less so in December. So we've got cooler temperatures. Okay, and a season is just defined as each of the 4 divisions of the year, so spring, summer, autumn, and winter, and these are marked by particular weather patterns and daylight hours caused by the Earth's revolution around the sun. Okay, and you will need to be able to look at a diagram and determine whether or not a certain position on the Earth will be in a certain season. So if we're looking at this, you can tell what season a position will be in based on if it's tilted towards or away from the Earth. So in this top one, it's winter. And if we look at the northern hemisphere, and when I say northern hemisphere, this can be a little bit confusing because these diagrams are shaded. The shading is just day and night, okay? The shading has nothing to do with the seasons. The hemispheres are the top half and the bottom half. Okay, so this top half, we're going to see if we're tilted away or towards the sun. Right now, the top half of the globe is tilted away. So the top half, or the northern hemisphere, is in winter. And then our southern hemisphere here is tilted towards the sun, so they are experiencing summer. Okay, these 4 examples are based on our experience in the northern hemisphere. Okay, so again, the northern hemisphere here is tilted away from the sun, so we are having winter at this position. Then if we move here, as we are moving along in our revolution around the sun, because of the tilt of the axis, we are starting to tilt towards the sun, so temperatures are going to warm up and we're going to have our spring. And as we continue in our revolution, eventually our top, or our northern hemisphere, will be tilted towards the sun and will be receiving large amounts of this solar radiation, which will be leading to very warm temperatures. And then soon, which is something that I am so excited for, we are going to start tilting back away from the sun in our northern hemisphere, and we will be experiencing fall. Okay. I don't know if you guys saw, but Starbucks came out with their pumpkin spice latte today. I don't really like pumpkin spice lattes, but I do enjoy fall and fall weather. So I still think it's a little bit early because it's still August and it is still 90 degrees outside, but the sooner fall can get here, the better. So just a common misconception is that Earth is warmer when it's closer to the sun. That is not true. We do not have seasons based on the position we are in our revolution. We have seasons based on the tilt of our axis and how we're tilted towards the sun. So if our hemisphere is tilted towards the sun, we are in summer, and if we're tilted away from the sun, we're in winter. Okay, and this is just showing that as well. And then 24 hours of light, 24 hours of dark. What? There is a movie called, I think, 30 Days of Night, but at the poles, depending on the time of year, with the maximum amount of the sun rays, there are certain places in the world, again, at the poles, that can be light, experience daylight for 24 hours, but also experience nighttime for 24 hours as well, which can be really detrimental to your circadian rhythm. I don't think I would want to live in a place where it was always dark or always bright. It's not forever, but it is for a little bit of time out of the year. Okay, so that's it for the seasons. So I'm going to cut this video here, and then we're going to jump into tides.